Section 949596, Part 2. Example 28. A surveyor stands 200 feet from a building to measure the height with a 5-foot tall theodolite. This is a picture of a theodolite, angle measuring device used by surveyors. The angle of elevation to the top of the building is 35 degrees. How tall is the building? So here's a couple pictures of people using theodolites out in the field. The key to this diagram, to this problem, is drawing the diagram properly. So we have our building. And we have the surveyor standing 200 feet away. Looking through their theodolite to the top of the building with an angle of elevation of 35 degrees. They're 200 feet away from the building. We're looking for the height of the building. The surveyor is 5 feet tall. We're looking for the height of the building, but the height of the building is not this x value, which is the opposite side of the 35 degrees. The height of the building is actually x plus the 5 feet. And that's why I was talking about in part 1 of the video, where there were a lot of problems where they were measuring from their feet and not from their eyes. And this is a much more realistic problem. So we're still going to be using right triangle trig. The building here is at a right angle. This is opposite, this is adjacent, so this is tangent. Tangent 35 degrees equals x over 200. Multiply both sides by 200. X equals 200 tangent 35 degrees. Go to our calculators. 200 times 35 tangent. And we get approximately 140 feet. Remembering that x is not the final answer. The final answer is add 5 feet to that. 145 foot tall building. Example 29. An airplane flying 3,500 feet above the ground begins a 2-degree descent angle of depression to land at an airport. How many miles from the airport is the airplane? Diagonal distance, x in our diagram here, when it starts its descent. 1 mile is equal to 5,280 feet if you don't know that. 2-degree descent angle. A lot of people will put the 2 degrees in here. That's incorrect. That would be measured from a horizontal. We mentioned many times in part 1 that angles of depression and elevation are always measured from a horizontal, not the vertical. So this is the 2 degrees. Okay? The plane 3,500 feet above the ground. There and here. So we can put the 3,500 here, we can put the 3,500 here, we can put the 2 degrees here, we can even put the 2 degrees here, all into angles. Either way, we're going to be using sine, opposite hypotenuse, or opposite hypotenuse. Sine 2 degrees equals 3,500 over x. Cross multiply. X sine 2 degrees equals 3,500. Divide both sides by sine of 2 degrees. X equals 3,500 over sine 2 degrees. 3,500 divided by the sine of 2 degrees gives us x equals 100,287.979 feet. But we want to know how many miles that is. So we're going to divide that by 5,280 feet. Figure that out in miles. Divided by 5,280 feet a mile. And we get x is approximately 19 miles for it to descend, before it lands. Example 30. The grade of a road or railway roadbed is a ratio of rise over run, usually expressed as a percent. For example, a railway with a grade of 5 degrees means it rises 5 feet for every 100 feet of horizontal distance. The Katoomba Railway, which this is a picture of, has a grade of 122%. What angle does the roadbed make with the horizontal? So rise over run, it rises 122 feet for every 100 feet of horizontal distance. We want to know what's the angle right here. We'll call that angle A. Okay. So this is tangent. Tangent of angle A equals 122 over 100. Inverse tangent of angle A is going to tell us the measure of angle A. Inverse tangent of 1.22 gives us 50.7 degrees, or 51 degrees of elevation. Example 30. 31. Use the given information and inverse tangent. Find the measure of angle A to the nearest whole number. So we're going to do inverse tangent of both sides of this, and then we're going to multiply by 3, because inverse tangent is going to give us A over 3, which equals 0.4663. Inverse tangent, 24.9996 times 3. So measure of angle A is equal to 75 degrees. Okay. Here, cross multiply. That's all for 1. Tan of angle A equals 0.5437 plus 0.5437 tangent of A. When I distribute the 0.5437 through this denominator, subtract 0.5437 from each side's tangent, and we're going to get 0.4563 tan of A equals 0.5437. Divide both sides by 0.4563. 0.5437 divided by 0.45 0.563 equals tan of angle A 1.19154, so on and so forth. Take the inverse tangent of both sides of that and measure of angle A this time is equal to 50 degrees. Example 32, simplify the expression tangent of inverse tangent of x. Tangent and inverse tangent cancel each other. They undo each other. Therefore, this is equal to x. Example 33, coordinate geometry. We use slope of line to find the measure of the acute angle forms with a horizontal line. So here we have an acute angle with a horizontal line, or an acute angle down here. They're alt angles, so it doesn't matter which one you look at. Slope of this line has an equation of y equals 3x plus 2. So the slope is 3, or 3 over 1. It's got a rise of 3, a run of 1. Tangent is rise over 1, opposite over adjacent. So the tangent of angle A, in this case, we're going to call it angle A, is 3 over 1, or 3. Inverse tangent of 3 is 71.6. So the shortcut is inverse tangent of the slope. So to the nearest tenth, find the measure of the acute angle that the line y equals 4/3 x minus 1 forms with the horizontal. Inverse tangent, so we'll call it measure of angle B this time, equals inverse tangent of 4/3. And we're going to round this to the nearest tenth. Divided by 3. Inverse tangent of that, 53.1 degrees. That's example 33. Example 34. The trigonometric ratios have been known for centuries by peoples in many cultures. The Polish astronomer Nicholas Copernicus, there's a picture of him, 1473 to 1553, developed a method of determining the sizes of orbits of planets closer to the Sun than the Earth. The key to this method was determining when the planets were in the position shown in the diagram, so that we had a right angle formed with the Earth, Venus, and the Sun. We had to have a right angle. When that angle was formed, then you could find the distance from Venus to the Sun. And then measuring the angle formed to find A being the length of the distance from Venus to the Sun. So if A is 46 degrees, how far is Venus from the Sun in astronomical units? Well, astronomical units is 1 astronomical unit is defined as the average distance from the Sun to the Earth. That is 1 AU, okay, or about 93 million miles. So in this problem, sine of 46 degrees is equal to x over 1, x being the distance from Venus to the Sun, over 1 being the distance from the Earth to the Sun. So Venus is approximately 0.72 astronomical units to the Sun. So with that in mind, if A is 22.3 degrees from Mercury, so Mercury is here, B, and this angle here, 22.3 degrees, how far is Mercury to the Sun? So just like we did here, where we had sine of 46 equals x, now it's sine of 22.3 equals x. So x is equal to 22.3 0.3, take the sine of that, and we get point. How far do we run? Let's go 2 decimal places. 0.38 astronomical units, or AU. How many miles from the sun is Venus? How many miles from the sun is Mercury? So if 1 AU is 93 million miles, then 0.72 AU, so 93 million, times 0.72 is 960,000 miles than Venus is to the sun. Mercury is going to be 93 million times 0.38. And that gives us 35,340,000 miles. Copernicus devised a method different from the one in parts A and B in order to find the sizes of the orbits of planets further from the sun than the Earth. His method involved noting the number of days between the times that the planet was in the positions labeled A and B. So this is a different planet outside of the Earth. His method of noting the number of days between the times of planets labeled A and B. Using this time, the number of days in each planet's year, he calculated C and D, calculated the angle C and the angle D. So for Mars, C was 52.2, and for D, it's 103.8. How far is Mars from the sun in astronomical units? So if this is 52.2 and D is 103.8, then this angle here is going to be 103.8 minus 55.2. Wrote the wrong thing here. Giving us 48.6 degrees. Okay, this is 1. This is this length that we're trying to find. Okay, so now it's cosine of 48.6 is equal to 1 over x. Cosine 48.6 degrees equals 1 over x. Cross multiply. X cosine 48.6 degrees equals 1. Divide by cosine 48.6. 1 over cosine 48.6 degrees. So x is approximately equal to 1 divided by 48.6 cosine 1.5 astronomical units. Okay, that's how far Mars is to the sun. Jupiter, 21.9, 100.8. How far is Jupiter from the sun? So I'm going to skip right down to, we'll call it y this time. Y equals 1 over cosine of 100.8 minus 21.9 degrees. Y is approximately equal to 8 minus 21.9, 78.9. So we're going to do 1 divided by 78.9 cosine equals 5.2. So Jupiter is about 5.2 astronomical units to the sun. Okay. I'm not making you look up the definition of an identity. I'm giving it to you. An identity is an equation that is true for any values you put in for the variable. It doesn't matter what you put into the variable. It's always a true statement. For problem 35, we want to show that parts A and B are both identities. We want to show that the left side of part A is equal to 1, and we want to show the left side of part B is also equal to 1. So let's take a look at our diagram. I mentioned earlier, not sure if it was in part 1 or part 2's video, that if we have a triangle ABC, little a is always the side opposite little angle A, little b is the side opposite angle B, and little c is the side opposite little angle C. So sine of angle B, I don't even need little a's and b's. Let's go with two of those. Sine of angle B is going to be side AC. No, we'll go with little b's. Is little b over little a, little c, squared, plus cosine of angle B is little a over little c, squared, equal to 1. So we have b squared over c squared plus a squared over c squared equals 1. Continuing this up here, I have a common denominator. B squared plus a squared over c squared equals 1. A squared plus b squared. Pythagorean theorem tells us that that's equal to c squared. So the numerator is c squared. The denominator is c squared. C squared over c squared is 1. Part B, 1 over cosine of angle A is b over c squared minus tangent of angle A is a over b squared equals 1. This becomes c squared over b squared minus, so 1 over b squared, c squared is reciprocal, minus a squared over b squared equals 1. Continue this up here. Common denominator of b squared, c squared minus a squared, b squared equals 1. Pythagorean theorem, c squared minus a squared is equal to b squared. B squared over b squared equals 1. 1 equals 1, check. Equals 1, check. Both are identities. Example 36. Firefighter on the ground sees a fire break out through the window near the top of the building. There is a voice contact between the ground and firefighters on the roof. The angle of elevation to the windowsill is 28 degrees. The angle of elevation to the top of the building is 42 degrees. The firefighter is standing 75 feet from the building. Her eyes are 5 feet off the ground. What is the roof to windowsill distance? What is this distance here? Call that D. Okay. Well, D, there are two right triangles here. call this one x, if we call this y, y is from here to here, x is here to here, right? So x is tangent 28 degrees equals x over 75. D is equal to y minus x. Anyway, and y is tangent 42 degrees equals y over 75. Solve for x, multiply both sides by 75. X equals 75 tangent 28 degrees. Y, multiply both sides by 75 again. Y is equal to 75 tangent 42 degrees. And D is equal to y minus x. D is equal to 75 tangent 42 degrees minus 75 tangent 28 degrees. And we pull out our calculator. Tangent, and we get D, or the height from bottom of the windowsill to the top of the building is about 25 feet. Minus 28 times. Yeah. Two different answers. Hold on. Let me just check my arithmetic. 42 tangent minus 28 tangent times 35. Sorry. Typo. It's about 27.7 feet. Times 42 tangent minus times 27.7 feet. Okay. Problem 37. Indirect measurement. Here's a simple method for finding a north-south line. Put a stick in the ground before noon and regularly march off the tip of the stick, the end of the stick, where it casts its shadow. Okay. When the shadow begins to get longer, stop marking. The closest mark to the stick, the one that is the shortest length, that's on the north-south line. Explain how you could use this method to find the angle of elevation of the sun at noon when the sun is at its highest. So here, when we're at noon, and we're on the north-south line, but if we're here, what does this look like? Here's the stick. Here's the shadow at noon, pointing north on the ground, and the angle of elevation to the sun is right here. Well, we got to know the height of the stick, and we're going to know the length of the shadow. So how would we find that? Inverse tangent's going to find that answer. So we'll call this tan inverse of the height of the stick, length of the stick, divided by the length of the shadow. And that's going to get us the angle of elevation equals sun angle of elevation, angle of elevation of the sun at noon. Okay. Example 38. For locations in the United States, the relationship between the latitude, cursive L, and the greatest angle of elevation, A, for the sun at noon on the first day of the summer solstice, on the first day of summer, June 21st, A equals 90 degrees minus L plus 23.5, or 23 and a half. Find the latitude of your town, then determine the greatest angle of elevation of the sun, for the angle of elevation for the sun of your town on the first day of summer. So I found the latitude for Westford on a previous section. Let me go look that up. So when I looked up the latitude for Westford, it's so Westford, latitude 42.5793. So A equals 90 degrees minus 42.5793 plus 23.5 degrees. So 90 minus 42.5793 plus 23.5 equals 70.9207 degrees. So there is the angle of elevation at noon on June 21st in Westford to the sun. Example 39. Find W and find Z. Okay. Now, I have had students make the mistake of doing the geometric mean, but we don't know that this is a right angle here. So we can't do geometric mean here. Okay? We don't know this is a right angle. Just because this is isosceles doesn't make this a right angle. We don't know. We do know that this is going to be 60 and this is going to be 60. Okay? Because it's isosceles and the altitude divides the base in half. So this is 42 degrees. This is 42 degrees. This is W is 60. This is 60 down here. So I found W. W is 60. We're going to use W to find Z. Okay? So to find Z, we use opposite, adjacent, tangent. So tan 42 degrees equals Z over 60. Multiply both sides by 60. Z equals 60 tan 42 degrees. Z is equal to nearest integer 2 tangent times 60. 54 is Z. Problem 40. Find the length of EF to the nearest integer. So let's find GF first. Find GF, call it X, and we're going to call EF Y. So to find X, we're going to go tangent of 35 degrees equals x over 355. Multiply both sides by 355. X equals 355 tangent 35. Y is tangent 44 degrees equals x over y. Just found x. Let's cross multiply. Y equal y times tangent 44 degrees equals x. Y equals x over tangent 44 degrees. We just found x is 355 tangent 35. So y is equal to 355 tangent 35 degrees over tangent 44 degrees. Go to our calculators. 35 tangent divided by 44 tangent times 355, and we get y is approximately, we're going to the nearest integer, 257 is the value of y, or EF, segment EF. Example 41. A certain jet is capable of climbing a steady climb at a 20-degree angle of elevation. How much altitude does the jet gain when it moves 1 kilometer through the air, diagonal distance? And we're going to answer to the nearest 50 meters. Okay, so let's draw this. (20°), 1 kilometer, and how much altitude does it get? Call that little a. Okay, so 1 kilometer is 1,000 meters. And we're going to do sine 20° equals a over 1,000. Multiply both sides by 1,000. A equals 1,000 sine 20°. 1,000 equals, is approximately equal to 342.0 meters. Rounded to the nearest 50 meters, 350 meters off the ground. Example 42. A 6-meter ladder reaches higher up the wall when it's placed at 75 degrees than when it's placed at 65 degrees. The ladder slides down as you pull it back. Okay, how much higher to the nearest 10th? We want to know this. Okay, so we'll call this x. X is from here to here. We'll call y from here to here. And we want to know how much higher is this. Okay? Well, we know that this doesn't change. This is 6 meters. The red 6, the blue 6, both times. Okay? and both times we're going to be talking about sine. Sine 65 degrees is equal to x over 6, and the sine of 75 degrees is equal to y over 6. Our goal is to find y minus x. So multiply both sides by 6. X is equal to 6 sine 65 degrees. Y, multiply both sides by 6. Y is equal to 6 sine 75 degrees. And we want to find y minus x, which is equal to 6 sine 75 degrees minus 6 sine 65 degrees. Minus 6, giving us a final answer of approximately equal to the nearest tenth of a meter, 0.4 meters, a little less than half of a meter that it slides down. Example 43, find the values of x, y, and z. Again, we don't know that this is a right angle. In fact, it's definitely not a right angle, because 25 plus 58 is not 90. So this is not a right angle here. Okay. Let's find the value of x first, using the 25 and the 32, and sine. So sine 25 degrees equals x over 32. Multiply both sides by 32. X equals 32 sine 25 degrees. X is equal to 13.5 approximately, and we round that to the nearest integer, so we're going to go with 14 is equal to x. To find y, let's use inverse, we'll use tangent, now that we know what x is. So we're going to use the 14. So we're going to go tangent of 58 degrees equals 14 over y. Cross multiply. Y tan 58 degrees equals 14. Divide both sides by tan 58. Y equals 14 over the tangent of 58 degrees. And we get y is approximately equal to 8.7, which is going to round off. Y equals 9. We have 14. We have 9. Pythagorean theorem is going to get us z. 14 squared plus 81. Square root that. Z equals 16.6, so round it off. Gets us 17. Example 44. Find u, v, and w, again to the nearest integer. Let's go with finding u first, because we have the 42 degrees and the 58. And that's going to be sine. Sine 42 degrees equals u over 58. Multiply both sides by 58. U equals 58 sine 42 degrees. 2 sine times 58 is approximately 38.8. So we're going to call U 39. Now that we've got U is equal to 39, let's find either V or W. Let's go for V this time first. So tangent, oops. Tangent 63 degrees equals 39 over V. Cross multiply. V tangent 63 degrees equals 39. V equals 39 over tangent 63 degrees. V approximately equal to 19.9. V equals 20. And again, I could use sine, cosine, or tangent to find W, but let's use Pythagorean theorem. So 39 squared plus 20 squared, or 400. Oops. 39 squared plus 20 squared, or 400, equals 1921. Square root that, and W approximately equal to 43.8. So W is going to round up to 44. And that's the answer for example 44. Thank you very much. Bye.